All right, so here we go. Our next video in Unit 12, talking about constructions and transformations, is reflections and symmetry. Today we're going to talk about what it means to reflect a figure to make a new image and how that relates to the idea of symmetry. What does it mean for things to be symmetrical? All right, so earlier we talked about a different way that you can transform an image called a translation. Remember, a translation is just when you move something. In this case, I took that apple and I moved it downwards to make a new image of an apple. And translations don't have to just go down. They could go up, left, right, down, or you could combine those to make it go northwest or southeast or any kind of crazy direction like that. But we're not going to do translations today. Today we're going to do reflections. And reflections are different than translations because it kind of spins or flips instead of just moving. And you can see that with the way that the image ends up of that apple when you do a reflection like this. So, reflections. Reflections use a line, and the line acts like a mirror. And the original figure gets reflected across that mirror line so that it makes a mirror image. And it looks something like this. If you have a line, and that line is like a mirror, you reflect the image to make your reflection. Okay, now that line, it's kind of like a mirror to make a mirror image. It's also kind of like a fold line. If you pictured this screen as a piece of paper, and you folded that piece of paper across that line, wouldn't the two apples overlap each other perfectly? Yeah. Well, that fold line or that mirror line is what we call a line of reflection. Pretty simple concept. It's the line that you use to make your reflection. Now, the thing about a line of reflection is it doesn't have to be horizontal. It can be vertical as well, and that would give you a different image for your reflection. And you can use a different vertical line too if you want to get a different reflection. Notice with all of these reflections, that line of reflection is like your fold line if this screen was a piece of paper. Now, your fold line, your line of reflection doesn't have to be vertical or horizontal. It could be crooked as well. And that would give you a different kind of reflection. Is that what you expected? Think again of this screen as a piece of paper. Wouldn't you have to fold it along that line to get those two apples to overlap perfectly and have their little bite marks overlap perfectly and have their little leaves overlap perfectly in the right direction? Yeah. Okay, these are all examples of reflections. Now, let's take a look at a reflection in the coordinate plane. If you actually were going to reflect this trapezoid, you could reflect it across the x-axis. You could reflect it across the y-axis. Let's try reflecting it across the x-axis. If we reflect it across the x-axis and I wanted to do point A, I'm going to have to take point A right here and I'm going to go towards the x-axis. Notice I go 1, 2, 3, 4, 5 spots to get to the x-axis, which means I'm going to have to go 1, 2, 3, 4, 5 spots from the x-axis, and I'm going to put a little dot there. Remember what I'm going to call that dot? I'm going to call it A prime. Oh, okay. I'm going to do the same thing with B and C and D. So B is going to go all the way across the x-axis, and I'm going to put a new B here. I'm going to call it B prime, and then C prime should be right about there. And then D prime is going to go 2 spots this way, so it's going to go 2 spots that way. And what do you know? Actually, I'll make that my trapezoid. And doesn't that blue trapezoid look like a mirror image of the original black trapezoid? Yeah, that's a reflection. And that reflection was a reflection across the x-axis. What if we reflected across the y-axis? Then what we would do is we would be reflecting across here. And when we do that, all of our points are going to be a little bit different. For instance, point B, instead of being 2 to the left of the y-axis, is going to be 2 to the right of the y-axis. Point C, instead of being 2 to the left of the y-axis, is going to be 2 to the right of the y-axis. Point A, instead of being 6 backwards from the y-axis, is going to be 6 forwards from the y-axis. And then point D, instead of being right here at -5, it's going to be over here at +5. And what do you know? I've got myself a new trapezoid, and my new trapezoid is going to be a reflection of the old trapezoid. Pretty crazy. Okay, so that is how you reflect a figure on a graph. Now let's talk about you doing this on your own. I'm not going to make you do a whole trapezoid, but I think you can take one point and you can reflect it across the y-axis. Oh, but wait, I didn't put an x and a y. You've got to remember which axis is the y-axis. All right, I think you can handle that. So let's talk about our next topic. Our next topic is symmetry, specifically lines of symmetry. A line of symmetry is when you have some kind of an object and you can split it right in half. Okay, you can see why that is a line of symmetry, because just like a line of reflection, could you fold this figure over on that line and have it overlap itself perfectly? Yeah, it would be symmetrical across that line. But is that the only line of symmetry for this figure? No, there are other lines of symmetry. There are other lines upon which this figure could be reflected onto itself, which is a fancy way of saying that lines of symmetry are just fold lines that you could use to fold that figure in half symmetrically. Obviously, you can do it vertically as well as horizontally, but there are even more lines of symmetry for this particular figure. Can you spot them? There's one. Oh yeah, you could fold it in half that way. There's another one. So lines of symmetry might be horizontal, or they might be vertical, or sometimes they might be crooked. This figure has 4 different lines of symmetry, but that's not one of them. And you can see why that's not a line of symmetry. If you folded that figure on that line, it would not overlap itself perfectly. All right, try these. We've got an isosceles triangle in the middle. You've got an equilateral triangle on the left. You've got a scalene triangle on the right. Are there any lines of symmetry for any of those guys? Well, for the equilateral triangle, there are 3 lines of symmetry. For the isosceles triangle, there's only 1 line of symmetry. Scalene triangles, you can't make any lines of symmetry because they're not symmetrical shapes. How about this? How many lines of symmetry does that polygon have? By the way, this is a hexagon. It has 6 sides. It has 6 corners. Obviously, you can fold it right down the middle. You could also fold it that way or that way. So there's 3 lines of symmetry. Oh no, wait. You could fold it either one of those ways too. So there's 5 lines of symmetry, but you could fold it that way too. That's funny. It has 6 sides and it has 6 lines of symmetry. Interesting. What about this figure? Where are the lines of symmetry for this one? Oh, nope, there are none. You can argue with me about that tomorrow if you don't get it. All right, and I could ask you how many lines of symmetry that thing has, and I could ask you how many lines of symmetry that thing has, but let's get to something even more challenging. What about this? Here's your second practice problem. How many lines of symmetry does that crazy many-sided polygon have? See if you can figure that out. Bonus practice problems. Sweet. If you do these, maybe I'll give you a little extra credit. The instructions here say to trace these figures, but obviously they're on your screen, so I don't suggest you start drawing on your computer screen right now. I do, however, think you could kind of sketch these freehand, and you could give me a general idea of what their reflections would be like if you use that line L as your line of reflection. All right, that's symmetry, and that's reflections, and that's the second of our 3 types of transformations, ways to change a figure into a new image. And that's it for today. Adios, amigos.